Good evening, everyone. I'm Janice Jones, as Meryl indicated, and I have the pleasure of introducing NCCCA Board Chair Joe Houde. Joe's had an illustrious career that's brought him to many places around the world. In fact, he's worked in over 50 countries, teaching seminars and consulting with business and government leaders. He's led workshops at over a dozen universities in the US, UK, Australia, South Africa, Middle East. He has decades of managerial experience and has worked as a counselor for people with disabilities, as well as with women and men affected by domestic violence. His educational background includes a Master's of Science in Electronics Commerce, a Bachelor's in Business Administration, and a Master of Arts in Counseling Psychology. Joe has had long-standing interest in the environment, and in 2018, he completed the climate reality training held in Los Angeles. And in addition to being NCCCA board chair, he is also chair of the North County Sierra Club group, and he's very involved with the United Nations Association, especially related to the Sustainable Development Goals. So with that, Joe, I'm ready to learn from you tonight.
Wow. Well, thank you, Janice. I must say, I that was breathtaking. What can I say? Now I've got to find my slides again. Where did they go? Ah, there it is. Well, good evening, everyone. Thank you for coming. I have been thinking since 2018, spent most of my time working on climate issues, and I've been thinking about how to convey where we are and how to frame the actions we need to take. And that's what I propose to cover in the next, actually, three sessions tonight, February and March. The first session tonight, I propose to talk about an overview of the planet's current environmental status and introduce the 9 planetary boundaries and especially focus on a segment where we'll talk about the interconnections between the boundaries. To me, this is one of the most important things for us to discuss because it leads to an understanding of what it is that it is possible for us to do, and in fact, required for us to do, in a sense, in local climate action plans and the like. Um, we will start walking through the boundaries. Tonight we'll deep delve into 3 of the 9 boundaries. Next session we will talk about the remaining 6 boundaries and summarize the status of tipping points on the planet. So this is big picture view and apply then look at how society is using the planetary boundary science. And we'll look at uh, how the boundaries are being used in economics, in health, in the UN's SDGs, and in other aspects of social endeavor, if you will. In the third session, I propose to spend the entire session looking at what we've learned about the boundaries and how they map the to a local climate action plan. Uh, and so everything in the third session will be what can we do locally, or what are we not doing enough of locally, and so forth. Uh, in truth, this is a difficult topic. We are we are in a great deal of stress and challenge, and at no level that I have seen are we doing what's necessary to protect life on the planet. It's not happening globally. It's not happening nationally. And as Meryl said, with our new administration, we're probably going to have terrible impacts. And it's not happening locally. Even the climate action plans that I've seen and commented on from multiple cities in the county and the county plan, there is much, much to be desired. So, what your involvement, our deep involvement in getting local action is fundamental to my thinking at this time, and uh, for especially the next 4 years, we really need to press hard. So, with that overview, I'd just like to take a quick look at where we are in one sense. I would say it would be remiss to not take a moment to pause and reflect on the tragedy happening in LA as we speak. Communities burning down, people dying. I saw this morning that one projection of the recovery cost starts at, as of this morning, at $52 billion. It's a powerful lot of money, and it's going to get undoubtedly larger than that as we keep going. And we've got another couple of days, apparently, of high winds coming. This is climate driven or exaggerated, at least by our climate inaction. And it's just diabolical and devastating. I think most of us on this call, I'll bet, know people who have been impacted already in LA, and we wish them well and and support them as best we can. When you look at what we've been up to, humans have been extracting. We started after we thousands of years of wandering around the planet in small groups, small family groups. We began building dams and trying to control water in Mesopotamia, and that led to states. And as we stored produce, that led to haves and have-nots and war, and eventually to nation states like Egypt, and then the empires like Rome, and to countries that we have today, uh, and the tensions between them. The industrial order that the West depends upon and has for the past, oh, I don't know, 500 years or so, I suppose, uh, leads us to a choice, a divergence. Will we break through and truly work on and resolve and heal the planet from the messes that we've made, or will we lead to social collapse? Uh, I think it's a knife-edge decision, and if we don't do all we can now, collapse is highly likely. We've extracted the metals and minerals from the earth and used them to, among other things, wage war on each other and on the planet. This is a picture of Europe, uh, I think after World War II. In 2024, in the fourth quarter, the UN held a climate conference in Azerbaijan. It failed. A biodiversity conference in Colombia. It failed. Struck out to pass a plastic treaty. We did not have a plastic treaty. It failed. We had a desertification conference, how we deal with the dry soils and the like in Saudi Arabia. It failed. Permitting reform in the US has failed. We have an administration led by some tragic leader who says, drill, baby, drill. And despite all the other things we've been doing, we have now in 2023 record demand for coal, even with all the clean energy we've deployed. And it's likely the demand for coal is likely to increase in 2024. Heartbreaking, heartbreaking. And we have stuff that's just been around for a long time. Right now on the planet, we have more than 30 active armed conflicts, none of them good for life, none of them good for the planet. This is a picture of some of the more than 500,000 craters that remain in Vietnam, a bunch of them with unexploded ordnance. Uh, from the war that we had in Vietnam a few decades ago. Uh, I was stunned to see that we had so many craters and so much destruction still that is not cleaned up and probably won't be for who knows how long. I'm going to offer a number of sources, references as we go through. And first, I'd urge you to look up, if you haven't done, uh, go to YouTube. Johan Rockström, who is the leader of the effort to identify the planetary boundaries, did a TED Talk, 18 minutes long in September. And in it, he says that by 2050, as we are proceeding now, we will lose 18% of global GDP to climate damage. And that's per year. And let me translate that again. It's $38 trillion per year in climate damage. So the 52 billion that we have so far in 2 days in LA is sadly a small taste of where we appear to be heading if we don't act. Now, I want to ask you to think about how will your friends and family, children, grandchildren, and so forth fund $38 trillion of repairs for climate damage? Uh, how are we even going to fund the repairs in LA? And undoubtedly, insurance costs will go up, and the going forward efforts will be uh, damaged a great deal by what we have done and what we're not doing today. The leader of the UN says 2024 has been a masterclass in human destruction. Well, you can see the pictures here. Uh, Brazil, you have floods, droughts, fires, hurricanes, a road out in California, typhoons in the Philippines, and so forth. And truly devastating set of dilemmas in weather events. In 2023 and 4 each, the US had at least 52 combined in the 2 years, multi-billion dollar weather damage events. Uh, and that's just the US, not talking about the loss of life in Libya when people floated into the Mediterranean and many other places. This is a picture from Spain a couple of months ago. Huge flood, kind of jumbled cars, pretty nasty. This is a picture from North Carolina. And notice the trees that are down here around this home, but trees were uprooted for about 200 miles through North Carolina, western North Carolina during the Helene hurricane. I like to read Bill McKibben's work, and I think he's a fantastic reporter and advocate. And in his October issue, 3 weeks into October, he said we have had major floods in only 35 countries in the first 3 weeks of October. I think, unless you track this carefully, I think many of us miss the global impact of the destruction that is underway. For the last 11 or 12,000 years, we have been in the Holocene. And the thing that's special about the Holocene is that weather has been and climate has been fairly stable and kind to us. Uh, Around the turn of this century, some folks have argued that we are now in the Anthropocene. And by the way, another reference, if you'd like, go to Apple TV, and there are other places too, and watch the movie titled The Anthropocene. It it has incredible images of what humans are doing to the planet. So in order to figure out how to respond to this chaos that we've created, we've identified, scientists in the world have identified the processes that regulate the planet, if you will. We've identified nine major processes that are uh, the fundamental planetary boundaries. And for each process, one of the questions that is on the table is how do we know we're going along safely, or how do we know that we have exceeded the places for a stable planet? And the the answer that the science world has identified for the moment, at least, is control variables. We'll identify one or several measures, and if we are uh, within the safe side of those measures, then we have no problem. If we're on the damage and in risky side, then we need to figure out how to move back into a safe place for life. Uh, there are many, when you think about control variables, there are many questions about, how do you pick one and which one do you pick? But in oceans, the scientists have chosen the acidity level in the ocean, but there are other measures like sea level rise, lack of oxygen in the ocean, suffocating fish and other life, the overturning of the ocean circulations in the Atlantic, and so forth. The food web being destroyed as corals die off from being overheated and the like. So there's a set of choices, and we'll look at the specific choices that the scientists have identified and why, and where we are with respect to the limits. If you think of the planet in terms of an analogy to the body, the Earth has organs. The rainforests uh, in Amazon and the temperate forests and so forth in the northern climes act as planetary lungs. The ice sheets in Greenland and Antarctica and the um, glaciers around the planet regulate the planet's temperature. And permafrost stores vast quantities of methane in Siberia and Alaska and so forth. Uh, you can think of all of these three, our lungs, our temperature regulation, and controlling greenhouse gas emissions and methane in particular, as uh, the core of things that we have to manage and stay within the boundaries for. So we need to pay attention to these systems and the nine planetary boundaries. Just this as an introduction, have been identified or described by the Lancet, the medical world, as Earth system boundaries. And Lancet has identified 8 Earth system boundaries, but basically the same kind of idea. Need to manage the planet's water system, our air system, our ice system, and our soils and rocks. And all of those are fundamental to ongoing good behavior for the planet or of the planet for life. We have to regulate, the planet is regulating these. We need to support the processes. So Johann Rockström and a group of scientists from around the world identified in 2009, first published a paper, uh, the planetary boundaries, and their goal was to identify the safe operating space for humanity. If you just think of your living room, if it gets up to 150 degrees, it's not very comfortable, and the like. So we need to be, at a safe place around these nine critical boundaries, if you will. One of the things that really intrigues me is the notion that the geosphere, the rocks and the soil, have co-evolved with the biosphere. And in fact, as life sprung up and uh, began evolving, uh, minerals on the planet also evolved, and there was kind of a co-evolution, if you will. If you'd like to learn more about that, Robert Hazen wrote a book called The Story of Earth and did a long class on the Teaching Company website about this whole process. Hazen is so well thought of in the geology world that we have a mineral named after him, hazenite. Uh, Absolutely wonderful presentation about the development of the planet from the Big Bang to where we begin life to today. Our core challenge, of course, is how are we going to live within the Earth's capacity? How do we do that? What does that look like? And to just now name the nine boundaries, there are three boundaries, climate, ocean, and ozone layer, that operate globally. There's no ongoing or persistent regional difference. There are four nature boundaries, biodiversity, freshwater, land systems, and nutrient cycles that vary around the planet regionally. We'll have different biodiversity mix, say, in the Amazon than we will in the Sahara desert or whatever, and so forth. So we need to look at the regional impacts as well as the global of these nature boundaries. And we have two boundaries that have been identified as sort of alien boundaries. Alien in the sense that without, before humans, they didn't exist. They're not natural to the planet. Novel entities are things that we make that have never been on the planet in the way we've made them before, and that obviously includes nuclear waste, plastics, PFAS, and other chemicals, pollution, endocrine disruptors, and the like. And the last is aerosol loading. We didn't have, in the way we, to the extent and the way we do now, smog and ozone hole problems and PM 2.5 in the atmosphere. I mean, that's got to be a disaster right now in LA, and so forth. One of the things that's interesting is that even though the aerosol loading boundary has been identified as alien, if you will, pollutants in the atmosphere help cool the planet by reflecting sunlight, but also cause something like 8.7 million deaths per year right now. So one of the most dangerous things that we're doing to the planet is disturbing the contents of the atmosphere. And as we identify the control variables, we eventually want to be talking about possible tipping points, things that we can't reverse. If you think about it for just a moment, if we melt the ice in Greenland and Antarctica, how will we refreeze it? If we have species go extinct, how do we reintroduce them to the planet system? First thing I would say is we need to declare a planetary emergency. We are in an emergency condition, and we need action on each and every one of the boundaries. Only a few cities that I know of in San Diego County, and probably fewer in other places, have identified even a planetary emergency for the city. But we really need to do that. We have to assume that we can phase out fossil fuels. If we don't, we will breach 1.5 degrees. In fact, we have already breached 1.5 degrees, at least for 2024. We're over around 1.6, I think, for the year, the hottest year on in recorded history, anyway. Um, if we not only have to pull back and be within the 1.5 degrees, actually probably less, ideally, we have other things that are stressing, the planet. A good deal of the CO2 right now that we are emitting is absorbed by nature. I think 93% of the heat uh, has been absorbed by the oceans, which of course is now disturbing the oceans terribly. But soils and forests also help buffer the planet. Where is the major risk? We talk about climate and heat, but if we disturb the endocrine systems on the body, that could turn out to be worse. Zoonotic diseases, perhaps you've seen in the past, I think it's less than 1 week, we have the first human death in the US from the bird flu. And we all know the mess that we got into with COVID and the like. So there are other risks that we can't afford to not pay attention to or ignore. And in fact, our food production system, as we will see, is another risky thing as we disturb our soils and pollute the soils and the planet with chemicals and the like. So just to reflect on, we're all focused on climate, and that's not bad, but we don't want to ignore the bigger picture, if you will. An organization called the Roundtable on the Human Future drafted a document called A World Call to Action. There are many organizations that participated. One I just highlight here, the Club of Rome, is fundamental to uh, the to a book. Oh gosh, I just blanked out the title. Um Earth for All, which has got 5 actions in it, if you will, that we need to take to protect life on the planet. Uh, but the World Call to Action says we're facing our greatest emergency. There are many interlinked and catastrophic risks pending, and human overshoot that is using more of the planet than the planet can sustain is underway. We have far too little awareness among people, among our population. And in fact, what this is part of what motivated me to want to do these presentations uh, that we're now beginning on. We need to mobilize millions of people. We just really do. And I know anybody on this call is already mobilized, and I thank you for that. It's really important. And we need to get many, many more people involved to address the polycrisis condition that we have. Uh, John Kerry, all around the world, people are failing or falling short and not even trying. It's very sad. And it's time for us to mobilize and do everything we can. There's a discipline, a group of people that have been doing something called ecological footprint analysis. And their analysis says that we humans have been using the Earth at 1.7 times the planet's capacity for renewal since the 1970s. And in fact, Earth Overshoot Day in last year was August 1st, and it'll probably be similar this year. Everything we did on the planet to use resources beyond August 1st was beyond the planet's ability to regenerate. And this is a stunning statistic from their research. If everyone consumed like the average US citizen, we would need 5 Earths. On the other hand, if everyone consumed the way that the average Tanzanian lives, we need zero point 0.7 Earths. Uh, Really interesting research here from their work. This is a link to their research, and it's a very interesting book that just was published. Oh gosh, I don't know, less than 90 days ago, I guess, titled "Overshoot" by Swiss scientists. Sorry, Swedish scientists. Andreas Malm. I really enjoyed the book. Where we need to be here in this chart is in the upper left-hand corner. We need to have uh, achieved social good behavior, and we need to not overshoot the planet's resources. And as you can see, the more wealthy nations like the US are overshooting the planet's resources, but no, but are have more measures of stability, if you will. The less wealthy countries are just the opposite. They are nowhere near using all the planet's resources. That's good, but the other side of that is they don't have very many measures of safety and equity underway. Just to summarize this in a graph, then, the uh, overshoot people were looking at the Earth system boundaries and where things are behaving with integrity. And as you can see, the Arctic, northern Russia, the desert in Australia, part of the Amazon and Africa are all doing reasonably well with respect to having a functionally
Yo,
intact
hey,
planet.
fat ass, can you hear me now? Can you?
Wow, I don't know what that was, but sorry. But if you look the US and across Europe and India and China and so forth, we are overshooting the resources on the planet in very serious ways. One of my favorite uh, images from all the planetary boundary work comes from economics. This is from a book called Donut Economics by Kate Raworth. And Kate framed this notion or pictured this donut, if you will, that on the outer ring of the donut is the ecological ceiling, and we need to be within, say, the climate change 1.5 degrees centigrade. We need to maintain the ozone layer to protect us from ultraviolet radiation and so forth. And then she also said in the inner circle, we have conditions of social equity that need to be framed and also need to function within a sustainable, ongoing way. And she's identified a dozen or so measures of equity. I'm sure you know a lot of the statistics, but just one uh, for not for the moment. Uh, the top 1% wealthy people on the planet have as much wealth as the bottom 90%. And the implications of that are just tragic. We probably saw Elon Musk put his thumb via his money on this last election. It may well have swung the election through his money. Uh, Very serious stuff at individual levels and at social and national levels. This is a first look at the state of where the boundaries are. I haven't said yet, but when this chart was published, this is September of 2024, we had exceeded 6 of the boundaries. We've now exceeded 7. Uh, the ozone hole is more or less stable. Atmospheric aerosol loading is still high with a lot of deaths, as we just said. However, it's getting a little better, in part because we are, for example, not allowing ocean ships to use high sulfur fuel, and therefore the aerosol loading in the atmosphere is decreasing a little bit. So that's getting better. But we have now passed the threshold for ocean acidification. And for all of the others, we are in the danger zone. The orange, yellow, orange, and red is the danger zone. And if you look out here at what's most at danger, it's fair to say nitrogen cycle is extremely dangerous right now. Climate change is very dangerous. Uh, Biodiversity is also very dangerous, and novel entities are off the scale. So there's several things we've done here that we'll come back to and look at in more depth that really need to be addressed and thought about. This is my favorite chart for looking at the boundaries. As we go through the presentation, we will define all these terms and look at them. But the core thing to see here is that in green, we are in a safe operating space. The planet is sustainable indefinitely, as far as we can tell, uh, if we're in the green space. As I said, ozone and atmospheric aerosol loading are both okay, sort of. We have now exceeded ocean acidification. In the nutrient cycle, we are far beyond where we should be with phosphorus and nitrogen. This is key to our food system. We have exceeded the freshwater boundaries. We'll come back and talk about those, and the land system, and biodiversity, and of course, the climate. So it's a really nice, simple picture, one frame of summarizing the state of the boundaries. These are interconnected processes that are addressing, but we're largely only thinking about one issue, or primarily one issue, the climate. But to stay within 1.5 degrees, interestingly enough, I would argue, and I think the science world argues, that we need to address all of the boundaries. Now, I'm not going to belabor this chart. You can come back to it if you'd like. You can have these slides, when we finish and so forth. But the point behind this chart, this is from the Planetary Boundary Science world, is that we have these 9 systems that are all interrelated with the others, and they all interact. And it's well worth coming back and taking time to think you through this chart and its implications. And this is the guide for the chart. The widths of lines and solid and dotted lines and so forth have different meanings. But right now, I'd like to identify or say these next 4 or 5 slides are arguably the most important in the whole presentation. So if you want to pay attention to one thing and really, lock it in, I would urge you to think about this. This is just a reflection on land use and land use change. The major factor in land use change is cutting down forests to grow food, to in in the Amazon, in Bolivia, and so forth, cutting down trees to grow to feed cattle, and then planting a lot of uh, cattle food, if you will, there, soybeans and so forth. Uh, there are other factors impacting our land use. We'll see a bunch of them. We'll see some of them, but let's just focus for the moment on the forest cut down for agricultural expansion. The moment we cut down the forest, uh, many, many acres per year, the ecosystem begins to degrade and multiple boundaries are impacted. Let's take a look. Forests transpire water more than other land types. They access the water through their in the soil through their deep roots, and uh, they put that water into the atmosphere. And as the atmosphere takes it, it rains, and that's why we have rainforests in a sense. Uh, Reduced forest cover means less transpiration, which then lowers atmospheric moisture. There's less moisture because there's less transpiration. This reduces the local and downwind precipitation around the ocean, around the forest, at the moment we begin to cut it down. The loss of forest then increases the near surface wind speed. There are less trees and leaves and so forth and green plants to slow down the wind. This then accelerates the drying of landscapes and decreases the time that moisture stays in the environment. Can you begin to see the Amazon drying out? It is. Trees release organic compounds into the air, which act as condensation nuclei to provide surfaces for water vapor condensation and result then when you have fewer nuclei, condensation nuclei, we have a decrease in cloud formation. Now, if you've been reading carefully the science of the past year and maybe two around the heating of the planet, we have decided that uh, the planet is warming faster than science models indicate it should. And we just in the past few weeks, some scientists have published the thesis that uh, decreasing clouds on the planet by if looked at from a distance away from the planet, we have 2% less land covered with clouds because of this phenomenon. And that is one of the main factors in increasing the the planet's temperature faster than we thought it was. There are fewer clouds to reflect sunlight and more energy than reaches the Earth's surface. Fewer trees also means less shade and cooling. Uh, this means temperatures will increase more. It results in open and dry understories, which increases the likelihood of forest fires, which then would release PM 2.5 particulates and harm the atmosphere and our breathing. Higher wind speeds then also increase erosion, and decreased rainfall increases temperature and water demands, which means farmers then use more fresh water for irrigation, which risks the water supply. Almost all of this then leads to a decrease in biodiversity, habitat loss, degradation, fragmentation, and the like. And increased heat and less shading and fewer clouds also decreases biodiversity. Rapid changes in climate that species have difficulty adapting to. You probably know that a whole bunch of species, mosquitoes among them, for example, are moving closer to the poles, away from the too hot um, equator areas of the planet. Altogether, this contributes to the loss of biomass and carbon that absorbs CO2, as well as the resilience of the plants and so forth, further accelerates climate change. And the increased agriculture increases the fertilizer use and the pesticides, which increases our nitrogen and phosphorus pollution, and among many other things, harms pollinators and uh, uh, makes oceans and waterways uh, without oxygen. So by consuming that oxygen, uh, they can less support much less life. Now, things we can do: afforestation, plant forests where there haven't been any for at least a very long time, or reforest. These would help and help mitigate climate change. But to think about this one change in land use, I hope we can see that nearly all of the planetary boundaries as we cut down forests get impacted. So when we uh, have that kind of condition and these kinds of natural interactions, we can't just say, let's reduce greenhouse gas emissions from driving our cars around. Or, we have to look at all of the boundaries and the impacts, and need to build a complex solution to the uh, actions that we're taking and that are in our climate action plans. We'll come back to this in the third session. We talk about how the planetary boundaries reflect into local climate action. But I think you can see right here from just this couple of slides that uh, there's so much interaction. We can't just uh, put our stake in one action or one limited set of actions. And 1.5 degrees means we have to return to 1.5 degrees to be safe for life, and we are nowhere near it right now. Just to build on this argument, after I built that first part of the argument in I think it was December of 2024, this organization, which is part of the UN, it's the IPCC something panel on biodiversity and ecosystem services, I think. They are writing a report called Nexus, this Nexus assessment. They have released an executive summary, which this information's from, but their full report is coming out later this year. Uh, they basically look at these five things: biodiversity, climate, food, water, and health, and ask how do they interact and so forth. Biodiversity loss puts food and water systems and human health at risk. Focusing solely on food security leads to terrible trade-offs because food security might mean cutting down forests, trade-offs with climate, water, and biodiversity. Shifting to sustainably healthy diets would benefit all of these five nexus features, if you will. All available options for restoring nature would also help to restore climate change, or restore our climate, I guess. And reforming the global financial system will help close the biodiversity challenges. So we have our economics involved again. And they say that we need to spend $7 trillion a year. We are spending $7 trillion a year right now globally that are invested in activities that are detrimental to the five nexus elements at the top of this slide. So we in a national and global sense, need some countries and UN or some other global body to really pay attention to this $7 trillion. And there's more yet in other areas that are that we're investing in ways that are harmful to life. Also, one of the things that's interesting is, how do we measure the complex of the nexus elements? We can identify climate change as having a limit of 350 parts per million and so forth. But how do we, what metrics uh, would help us capture all five of these in some meaningful way and know that we're doing better or doing or surviving, building a survivable system with this? Interesting question, and uh, one of the things that we will come back to time and time again is, well, what do we measure to know that we're doing well or not? And that's undefined here at the moment. Homework assignment for everybody. And this is a chart from that Nexus executive summary that talks about land use change impacting, uh, disconnecting us from nature. Uh, Increased contact for wildlife is probably not good. Look at COVID. We have unsustainable agriculture, increased greenhouse gas emissions. You can read through the chart at your leisure. But basically, the moment we change land use, this is another way of describing what we've already just talked about here, that uh, every one of these five nexus elements impacts the others. So, with that framework and introduction, I'd like to take a few moments to step through our climate system and where we are with it. Obviously, the core issue here is heating. Our target, 350 parts per million. I was surprised to learn that heat kills more Americans than flooding, tornadoes, hurricanes, all combined. And perhaps you noticed in mid 2024, the Hajj, the Muslim pilgrimage in Mecca, 1,300 people died because it was too hot and they couldn't get enough water and they couldn't cool their bodies down enough. And that was just in a day or two. Uh, Heat is serious stuff. For one-third of the days in 2023, our average temperature was 1.5 above 1.5 degrees. In fact, in 2024, we've exceeded it for the year. Malawi, this is just a small data point. There are many stories like this. Malawi had a period in 2023 where they were 20 degrees above average, 20 degrees centigrade, 32 Fahrenheit above average. You probably saw Phoenix had months and months above 100 degrees and 5 weeks or so above 115 every day. And there's lots of those stories to tell about heating. And hundreds of new fossil fuel projects have been approved. Biden has approved the Willow project in Alaska. Undoubtedly, the new administration is going to approve methane gas terminals, not methane, natural gas terminals at, well, there's methane, in the South Coast and the like. Uh, so while we are in bad a shape as we are, we're approving hundreds of new uh, projects. We also seem to have no will to tax carbon emissions. When the government is funding a project that has emissions, they use an offsetting amount called the social cost of carbon. That is, when CO2 is emitted from burning oil or natural gas or whatever, uh, the the oil companies don't pay for the cleanup. We pay for the cleanup. This is in economics called the externalities. And the federal government's current social cost of carbon, the offset, that what they charge, if you will, or allocate for cleaning up a ton of carbon is something like $185. There was a very interesting research project, research released in 2024 that said, no, the real social cost of carbon is $1,056 per metric ton to clean it up. The worst case that I've run across is some researchers said $6,200 per metric ton. But let's just think about this for a moment. We are right now emitting 61 gigatons in 2024 of CO2 and of greenhouse gases collectively. At $1,000 a metric ton, that says the cost to clean up the carbon that we emitted in 2024 will be something on the order of $61 trillion. I ask again, how are our children and grandchildren and so forth going to fund $61 trillion to clean up the carbon emissions from 2024 and more every year? No major oil company is close to aligning with the Paris Agreement. In fact, there is a UN initiative to ask oil companies to sign to commit to reducing emissions. And all of the major oil companies on the planet in the past few months, especially since Trump was elected, have backed out of that agreement. They all signed up to reduce emissions, and now they've all decided, no, we get too much profit on the table, and every one of them is backed out. And we know in the Arctic and the northern climes, things are especially hot, but not just there. If you look at the map of the planet, there's no place where we have real cooling going on. This is, to me, is a very disturbing picture. This is an Exxon plant in Texas. It is one of the worst emitting places on the planet. We're in a dance of death with the fossil fuel companies, and we as a culture refuse to recognize it, or at least to act as if it's truly a dance of death that I'm convinced it is. This is a chart from the UN, I think, some UN researchers that suggests that we are emitting CO2, methane, nitrous oxide. By the way, this is 300 times more climate warming potential from nitrous oxide than from CO2. The F gases and LULUCF is land use change, and forestry, cutting down trees and the like. And they're all contributing here to the warming. And this report says that we are at 57 gigatons of emissions this year. We're headed to somewhere around 3 plus or minus a little degrees centigrade by the end of the century from this report. And I will show you later when we talk about climate trace that we've actually measured 61 gigatons that I've already referred to. We'll show you how that comes about. And of this power, industry, transportation, buildings, food production, industry, agriculture, cutting down trees and the like this is the split, the breakout of where we are and what we need to be focusing on each of these. What's interesting to me here is we have the blue line on the bottom, blue purple line, is where we need to be with emissions to stay within 1.5 degrees. And this says by 2050, we need to be down collectively to 10 gigatons. But where we're actually at now is this red line way up here. And we are within probably not more than 5 years at the rate that we're going of breaking the budget for 1.5 degrees. And there's little reason to believe. I don't think there's a chance in hell, really, of staying below 1.5 and maybe not 2 anymore. This is another picture of the same kind of thing. This is looking at historical trends or current policies far, far above where we need to be for 1.5 degrees. Nitrous oxide, which nitrogen is used as a major uh, fertilizer for food growth, destroys oxygen, and interestingly is not controlled by the Montreal Protocol that has begun to heal our ozone hole. Uh, the global warming potential, as I said, is 300 times that of CO2. We need huge, strong action to eliminate 235 billion tons of CO2 equivalent. Uh, we probably, well, this says 5, 6 years. There are probably 5 or 6 years left. And if we could control the nitrogen, we would have a benefit far bigger than, removing CFCs and the F gases that have warmed the planet. Actually, nitrous oxide, if we continue using so much nitrogen fertilizer, threatens the benefits of the Montreal Protocol and could further damage the ozone hole or prevent us from healing it. Half of the world's food today is produced with synthetic fertilizer, read nitrogen and phosphorus, if you will, much of it to feed cattle. And if we reduced feeding cattle, we could produce less food, use less fertilizers. And we all know switching to plant-based diets is a very positive thing for the planet. A second measure of climate, of heating rather, is uh, called radiative forcing. It's measuring heat, if you will, at the top of the atmosphere. It measures all of human activities, not just CO2, but methane and the others that we've mentioned, and aerosols and land use changes and so forth. It's a direct measure of the change in energy at the top of the atmosphere and identifies how much is being added or subtracted from the climate system. What we should have, what we need to be safe, is 1 watt per square meter, and the value today is nearly 3 times that. So this is a second measure, if you will, of the boundary for climate. And, this also, we are far beyond where we need to be. The planet's energy balance, you can see the boundary at 1 degree C and where we are up around, far, far beyond that. We will come to a point, we already have measures or measures of uh, unlivable conditions, if you will, like that happened at the Hajj, a combination of humidity and heat. And we come to a place where uh, we can no longer survive. Our bodies are so hot, but they can't perspire, and we quickly uh, die. And where we're headed right now in all these, this is 197 cities. Look at India, Saudi Arabia, Sub-Saharan Africa, much of the Amazon, Central America, Mexico, and the like, much of Australian desert. All of this is coming to a point where if we get to 2.7 degrees, we will not be able to live in those places. We talk about immigrants and migration. People will either migrate from there or die if we get to that temperature. And this is the map of the global temperature energy balance at the top of the atmosphere. And you can see all the reds and pinks are where it's too hot, which is most of the places that people live, and some on the oceans. What do we do to deal with climate? Well, we have to target a maximum increase of 1 degree C, I think, to be really stable, and 350 ppm for CO2. We need to stop burning fossil fuels. We're going in the wrong direction in every way in that. And movies, Chasing Ice, Chasing Coral are two interesting movies that describe some of the impacts of heating on the planet today. Highly recommend them. The second of our boundaries, the ocean system. Uh, I think I mentioned, what do we measure to know that the ocean has been, the ocean system is unstable? Sea level rise, that impacts a great deal, of course. Plastic pollution in the ocean is devastating. Uh, there are minerals in the bottom of the ocean that are can be used for batteries that some organizations want to mine and get profits from, but would disturb the life, the ecosystems on the ocean floor. And so that's another measure. And the populations of life, corals, 25% of the ocean life lives in coral reefs in and around. We had overfished cod uh, decades ago, and it's been decades since we stopped doing that, but the cod has not recovered. We also have a huge devastation of sharks, the killing of sharks. Uh, we have tremendous value and benefit from planting and nurturing seagrasses and mangroves, and that's things that I think we should take a serious look at on all of our coastal systems. Ocean acidification. The bottom line here, I can state it fairly simply, is that aragonite is a form of calcium carbonate that oysters and clams and corals use to grow their shells in their bodies. And the the boundary is set at 2.75 units. I don't remember what the unit was. And the current value is 2.8 and falling. It's actually fallen now. So we have exceeded this boundary. I need to update this chart, this slide. Uh, if the uh, shelled life and corals and so forth in the ocean can't uh, survive, then it being at the base of the food chain, the ocean food chain, means the ocean food chain will be in terrible shape. Uh, this is a picture of degraded coral. You can watch the movie Chasing Corals and see many, many others. Um, so the damage from ocean acidification is losing the coral reefs, including the world's largest living structure, probably the Great Barrier Reef off Australia. Shells can't be created. We disrupt the ocean food chain, reduce the human food supply. Acidification of blood happens even, and marine population is continually near death because of acidifying blood in those beings that aren't making shells and the like. There's a tremendous loss of biodiversity from acidification. Oh, I love to research personally and read about human or planetary history, and we have had five prior extinctions. The one 252 million years ago, the Permian Triassic was the largest. 90% of the ocean's population died due to ocean acidification, and we're trying to reproduce the Permian Triassic extinction in our oceans with our behavior. Batteries we know are needed for clean energy, and the nodules on the ocean floor contain lithium, cobalt, nickel, etc., magnesium, etc. When the nodules cluster together, they actually can create a battery which will strip the O from the H. It's the only known production of oxygen in nature that does not come from photosynthesis. We know that on the ocean floors we have many not even understood yet ecosystems. That oxygen is very likely supporting those ecosystems. Uh, and if we go do the mining, then the ocean floor ecosystems are likely to be devastated. Every time we go to the ocean floor, we find new forms of life that we didn't know existed. Some quite extraordinary in their capacity. This is a measure of ocean acidification, and you can see the brown says we have too little uh, uh, carbonate, and this is a projection or prediction on the from 2000 we had this is from a model a lot of uh, not saturated or saturated with aragonite. Uh, by 2050, we have far less, and by 2099, at the rate that we're going, we will have truly devastated the oceans with acidification. Some of the many implications, I just thought I'd toss in a couple here. Uh, the Los Angeles San Diego train was stopped for 6 months in the past year and a half or so because cliffs fell in because of sea level rise. Uh, we probably have to replace the tracks on the cliffs at Del Mar uh, that are just a couple of feet from the edge of the cliffs. That means a tunnel. That means billions of dollars of expense and delays, or we no longer have a train system from San Diego to anywhere. So this is a pretty serious consideration. Carlsbad has a road by the beach that is at basically at sea level. The city, I think, has decided they have to move it inland because it will be too flooded. Uh, we have uh, too little in the way of seagrasses and so forth along our coast. These are just some of the issues. We know about melting. This is a projection of melting over time of the Greenland ice sheet. By the way, if Greenland ice melts, we probably have 24 feet of sea level rise. We can say goodbye to the southern half of Florida. We'll certainly be underwater by then. And if all of the Antarctic ice sheet melted, we probably have 10 times that, 240 feet. So we're talking about the possibility of 300 feet of sea level rise. There are vast populations of people and cities on ocean fronts, on all continents. What are we going to do with those people? Where will they go? And our last little bit for tonight, the ozone layer um, is was being depleted by emission by F gases as they got into the atmosphere, thinning the ozone layer. This is measured in Dobson units. One Dobson unit is a layer of ozone that is 0.01 millimeters thick. And typical values range from 100 to 500 Dobson units. The current value is 285, so we're pretty safe at the moment. However, we do have a persistent ozone problem over Antarctica. What is it all about? Well, ultraviolet radiation that the ozone layer blocks causes skin cancer, rubber to crack, uh, and the hole over Antarctica is serious, close to record size in 1023, uh, possibly due to volcanic eruptions undersea. And we're on the way to healing. You can see 1971, the ozone hole was pretty intact. 2017, a disaster. 2041 expected to be better. 2065 improving, but by no means healed to the point that we need to take it. So next time we will pick up talking about biodiversity and the other boundaries. I hope I didn't overwhelm you all too much tonight.
Thank you very much, Joe. That was really fascinating and a lot to digest. There haven't been any questions come through in the chat yet, but if anyone has any questions for Joe, please enter them into the chat. I think the fact that there aren't any questions is because of the intensity of the information you presented and the need to process it.
Yeah, I appreciate that. We could begin the next session with questions if people once they do some processing, if that would be helpful.
That's a great idea. Yeah. So we weren't quite done yet. Any other comments from Meryl or Marion?
I do agree with you. That was a lot to process, and I appreciate so much how thorough you are, Joe. You leave no stone unturned in your attempts to mitigate the climate crisis. So we really greatly appreciate you for that. So thank you.
You're
And
welcome.
Meryl,
We really truly need to look at all of these dimensions, and this is where our climate or environmental action needs to be.
well, I see a question did pop up here. It says, is there any way to access your excellent slides in order to review them before the next talk?
Yes, I could, if you'd like, I could send them to you, to Meryl, the part that we've just covered, and then Meryl, when you release the link, sorry, the recording link, you can include the slides, and we can do that for the next two sessions also. I think it would be useful to review them to be sure, and I'm available to discuss them, independent of these sessions if anybody wants to, carry on the dialogue.
Yes, there will be a copy of this recording on the YouTube, and it'll also be on our Facebook page, and I will include it in next month's newsletter that comes out on the 1st. So if any of you want to sign up for that, just shoot me an email, and I'll make sure that you're included. And we'll include the links too, because I saw a number of things that I wanted to follow up on, especially that one 18-minute video you were talking about with what I can't remember his name, Jonathan.
Johan Rockstrom.
Johan. Okay, yeah.
Mhm.
So definitely we'll do that. And then we have somebody named Jonathan. Do you mind if I jump into this, Janice? Okay.
No, go ahead.
And Jonathan said, I would like to write and illustrate a book on climate change, and I would like to get connected to individuals or organizations that have a lot of scientific facts and info about it. And so if you know any of those resources. So definitely you're kind of in the right place here with this group. So I'm sure that Joe would love to reach out to you and talk to you about that individually. Am I speaking for you, Joe? Is that okay?
No, you're doing fine.
Okay.
I
And
might I might just say here in 2009, Johann Rockström and a group of scientists, global group, released the first version of the planetary boundaries. And at that time, we had exceeded four of the boundaries. 2015, they did an update and we had exceeded six rather. And 2023, they did a second update and we'd exceeded, uh, sorry, it was four, five, six, and now seven. And in 2024, they released the first of what it meant to be annual updates. And they're inviting the scientists from around the world to participate. And one of the things they want to do is build a dashboard that covers the status of all of the boundaries and make it available globally. And
Mhm.
anybody who's interested or knows about how to put together the dashboard and how to capture the data for these measurements, for example, you can look around the coasts of nearly every continent, and there are acid measures, if you will, in the ocean. It would be easy to capture that data and the like. But this is an ongoing initiative that I think is probably the most important globally, in my view, anyway, that I've seen in terms of uh, trying to understand where we are and then by extension what we can be doing, which we should be doing.
I
Sorry.
would also suggest to Jonathan in doing research for your book to check out our YouTube channel and just do a skim over all the different talks that we've had. And if any of those interest you, you could probably get in touch with the people that did those talks. So anyway, Meryl.
Marion Shiwa had a similar question. She said she wanted a copy of the recording, and
Mhm.
Shiwa, that will be available on the North County Climate Change Alliance YouTube channel.
Correct. Okay. So Meryl. Okay, Joe. No big surprise here, right? Uh,
No
this
big
is our
surprise.
this is our tradition here. We always like to thank our guest speakers with a tree that we have planted in your honor in an area that's been sadly affected by the wildfires previously. In my personal opinion, Joe, you deserve a whole grove, but we'll have to start off with just one tree for now. But
That's more than enough, Marianne. Thank you.
But anyway, but thank you. And also big thank you to everybody who came. And it was really great to see some new people here. So I do hope that you will join us for part two. We'll be sending out that registration link with the next newsletter, and also that will be posted on the website as well. So anyway, thank you everybody so much. And I'm going to say good night. So
Yeah,
take care,
and the
everybody.
part two and three are on the second Thursday, right?
Yes, the
Yeah.
second Thursday, correct. Okay. Thank you
Thank
so
you.
much. Take
Thanks,
care. Bye bye,
everybody.
everybody. Bye.